In this video, I'm going to be solving some introductory trig equations. It's going to be maybe your first exposure to solving equations involving sine x. Something like sine x equals a half. Maybe we'll look at, maybe a little more advanced equations, but we're just getting started on this. So you remember from last unit, when we had a triangle that was set up like this, and we wanted to find the value of theta, and we had two side lengths, we could set up a trig ratio saying something like, sine of theta is equal to 1/2. And then we said that really what we were doing was we were taking inverse sine of both sides. So that would be inverse sine of sine theta equaling inverse sine of 1/2. Now, we only did that the once, right? Because then we realized that if we said sine theta equals 1/2, then theta is equal to inverse sine of 1/2. And we threw that in the calculator and we got 30 degrees. Okay, now we know that 30 degrees is probably better said as pi over 6. And sure enough, if you go into your scientific calculator and you do, let's see, you need it in radian mode, I suppose. You do inverse sine of 1/2, inverse sine of 0.5, you're going to get 0.52359. And just to verify that this is pi divided by 6, I'm going to multiply this by 6, and we should get pi. And that looks like, well, at least the first couple of digits pi. I don't know the rest of them. I know 3.14. Right? Okay. Now, the thing about this example is it's valid for this triangle situation. But there are other places where sine is equal to 1/2. If you think about the unit circle, we know that sine is the y-coordinate. So, and we know that, we could say 1/2, that's kind of small. So what if we just said the y-coordinate is equal to 1/2? Well, I'm seeing two places I've run into the unit circle, right? We're seeing this pi over 6, but we're also seeing this other place here. This would be pi over 6 before pi. So that would be almost pi, but less by pi over 6. So that would be 5 pi over 6. So I'm going to go in and I'm going to look at 5 pi over 6. Okay, I'm only going to look at this portion of the unit circle to make it look a little better. But yeah, just like we do. Okay, I didn't like that. Try that again. There we go, that's better. Okay. This is a 30, 60, 90 triangle, so this leg was 1/2, this leg was root 3 over 2, and this leg was 1. Now, since we were in the second quadrant, that's where the horizontal leg would be negative and the vertical leg would be positive. But sine is the length of the vertical leg on the unit circle. So this is sine is 1/2, right? Sine theta equals 1/2, where theta is 5 pi over 6. Okay, so we're seeing that maybe when the calculator runs inverse sine, it's not giving you the whole picture. So there are two solutions that we know of. But then you think last time we talked about going backwards on the unit circle or going around the unit circle more than one time, right? I could say that those same points, if I went backwards on the unit circle, I could go backwards, let's see, that's pi, and then another pi over 6, negative 7 pi over 6. That would be a solution, because that would leave you kind of in the same place on the unit circle that you'd been otherwise. Or what if we said we went all the way around the unit circle once and then went another pi over 6? Well, that would be 12 pi over 6 plus another pi over 6 is 13 pi over 6. And really what you could do is you could just take pi over 6 and 5 pi over 6 and add 2 pi, subtract 2 pi, and you could get an infinite number of solutions. And we'll see why this is the case when we go and look at the graphs of sine and cosine, I think next time. But it's good to keep in mind that in general, if a trig equation has at least one solution, and it's just in sine or cosine, then it will have infinitely many solutions. Okay, something like x plus sine x might not have an infinite solution, but that's a different discussion. But what I'll tell you is for this class, we're just going to worry about theta values between 0 and 2 pi. This is already kind of beyond what you would typically study in a college algebra course. This is mainly for the few of our kids that are going to go on and take calculus next year, whether it's, at this school or somewhere else. If you're expecting to be in calculus, you might need to be able to solve trig equations and consider theta values outside just the first trip around the unit circle. Okay. And before I move on, I'm just going to kind of remind you about some things about the unit circle. I'm only going to kind of draw the first quadrant. It's really not a very good circle, but it'll do. Okay. We looked at the extremes like 2 times ago. We said this point had coordinates 1, 0, x was 1, y was 0. Up here, this point had coordinates x was 0, y was 1. Okay. This was theta equals 0. And this one was theta equals pi over 2. That's got to be, yeah, it's outside of my window. Whoops. Okay. Now you can see that. Okay. Then there were the pi's over 6. Like 1 pi over 6 was here. And the coordinates of that were, okay, root 3 over 2 and 1/2. And then over here, that was theta equals pi over 6. Then 2 pi over 6, or pi over 3, and this drawing is definitely not drawn to scale. I'm spacing them out so I can fit all this information in the graphic, but, oops. Because you can see, this y level is not a half, right? That's not halfway up. I'm drawing it out of proportion so that it looks better. Okay, this is where x is 1/2 and y is root 3 over 2. And I'll show you why that's useful, to draw it kind of not to scale. This is theta is pi divided by 3. Then in the middle, we have theta equals pi over 4. And that's where both of them are square root of 2 over 2, because it's a 45, 45, 90 triangle. Now the thing is, the way they really sit, pi over 6, pi over 4, and pi over 3 are actually kind of close to each other. And it can be difficult to tell which one you are looking at if you draw it too accurately and, it's okay, I see it's kind of towards the middle. I don't know if that's pi over 4, pi over 3, or pi over 6. But if you draw it more extreme, it'll be easier to see. So just in terms of x, I'm going to just order these, right? It starts off with pi over 2, which has the least x, where x is 0. And I'm just going to draw along here in pink. And then as I move to the right, okay, theta, or x equals 1/2, then x equals root 2 over 2, then x equals root 3 over 2, and then x equals 1. Okay, that's the larger x's. So what I'm going to remind you of is something I told you, I think at the beginning of this unit or somewhere along the way, is that, okay, of course 0 is going to be the least. Then there's 1/2. Then there's root 2 over 2. Now root 2 over 2 has to be bigger than 1/2 because the square root of 2 is bigger than 1. And then root 3 over 2 is bigger than root 2 over 2. And then 1 is the biggest, because 1 is basically root 4 over 2, right? If you think about it. Okay. So, if you remember this, you say 1/2 is the really small one. Root 3 over 2 is the pretty big one that's not quite 1. Okay? This will make it easy to solve these equations, provided you know your stops along the unit circle. All right, here we have cosine theta equals root 3 over 2. This is a very typical example. Okay, the steps I'll tell you to take is going to be, 1, start by drawing a unit circle. Then you're going to draw a little dotted line or a line to find where x or y fits the equation. In this case, cosine is going to be root 3 over 2, so we're going to find where x is root 3 over 2. And then we'll choose out the theta values. So first thing I'm going to do is draw a unit circle. Then you're going to say, well, root 3 over 2 is pretty big. It's the one that's pretty close to 1. And cosine is the x-coordinate. Okay? So I'll come back through, and I'll say, well, it's pretty close to 1. Okay? Now, root 3 over 2, probably not that close to 1, but what I'm saying is that if you make it closer to 1, even still, that wasn't a great drawing. You just want to draw it bigger. Hold on a second. Let me draw that again. All right, that one's also pretty lopsided, but it'll be fine. Okay, so you go really close to 1, and then you go, these are the places where the x-coordinate is 1, or is root 3 over 2. And you see we kind of hit early on. That's going to be pi over 6. And then we also hit almost all the way to 2 pi. Well, that's 11 pi over 6. But right, we learned last time we could also call this negative pi over 6. Really, whatever you think. Okay, and then those are the theta values. Okay, so that means that theta equals pi over 6 or 11 pi over 6. All right, next I've got one where sine theta equals root 2 over 2. So I'm going to start by drawing a unit circle. Okay, now root 2 over 2, that's something that you should see, and you know that comes from a 45, 45, 90 triangle. So you're expecting this to come back some kind of pi over 4. It's equal to something over 4. Okay, and we'll figure out what that is. But because of the root 2 over 2, I know I'm expecting one of the pi's over 4. All right, well, sine theta equals root 2 over 2. I'll kind of say, okay, well, sine is positive. That's going to be, above the x-axis. And it's going to happen at one of the pi's over 4. So root 2 over 2 is the one in the middle, so it's going to happen here and there. You could also kind of draw a little line like that if you wanted. Okay, but this is going to be pi over 4 and 3 pi over 4. So you conclude that theta equals pi over 4, or theta equals 3 pi over 4. Okay. So we're drawing a unit circle, we're drawing a little line to figure out, how high or how far over it is, and then we're pulling back theta values, right? Because we're solving for theta, just like before in this class we solved for x. Okay, next I have some that are going to be, the extreme values on the unit circle, like we looked at last time. Or I guess that was the time before. Sine of theta equals -1. Well, -1 is as big as sine can get. We saw that was up at or -1 was as negative as it can get. Okay, we saw that happened at the top and bottom of the unit circle. Right? Okay, if sine is y and y is -1, that only happens right here. And we know what that is. That's 3 pi over 2. So I can conclude that theta is equal to 3 pi divided by 2. Now, yes, we could also call that negative pi over 2. You could call it 2 pi plus 3 pi over 2 would be, I don't know, I think 7 pi over 2. There are lots of names for that same point, but that's where sine of theta is equaling -1. Then if I were to draw a little unit circle and try to find where cosine is 0, cosine is the x-coordinate. Right? So, where the x-coordinate is 0, that's this. Okay, so I kind of go up there, and I've found one, and I go down here, and I've found another one. Okay, that's theta equals pi over 2, and that's theta equals 3 pi over 2. All right, next, it's like, well, what do you do if you see cosecant theta equals -2? I'm not really familiar with the values of cosecant on the unit circle, okay? But you do know that cosecant is the reciprocal of sine, okay? So what I'll say is that you need to take this and transform it into an equation involving sine or cosine. And we can do negative 1/2 because we'll draw the unit circle. Okay, sine is the y-coordinate, and it's negative 1/2. That's not very negative. That's pretty early on in the unit circle. Okay. It's the smaller one. So I go over here, and I found two places where that happens. This is 11 pi over 6, and this is 7 pi over 6. So I conclude that theta is equal to 7 pi over 6, and theta is 11 pi over 6. Again, because sine is the reciprocal of cosecant, and sine, it corresponds to the y-coordinate. Okay, so the y-coordinate is not very negative, but it is negative. You go down a little bit, that's 7 pi over 6 and 11 pi over 6. Like I did in blue. All right, here's an equation that's got a little more going on. And it's 4 cosine of x plus 8 equals 6. Okay. So what we're going to do is we're going to solve at this thing just like we solved at x in previous units, right? We're going to start by, we're going to really undo our order of operations. We're going to start with the addition and subtraction and get rid of that. So I'm going to subtract 8 from both sides. That's 4 cosine x equals 6 minus 8. Then I'm going to divide by 4, and that's negative 2/4 is negative 1/2. Okay. Then I'm going to take inverse cosine of both sides. And if you're working in degrees, that's great. But, you know, just I'll tell you, the test that we've got coming up is going to be in terms of radians, so that won't help you all that much. Unless you know the conversion factor, which is just all of a sudden too much stuff to memorize. So you're better off getting it down to here, cosine equals negative 1/2. Well, I know that cosine is the x-coordinate, and that negative 1/2 is negative, but not very negative. So I kind of like find where that happens. And the first stop past pi over 2 is 2 pi over 3. And then the first pi over 3 after pi would be 4 pi over 3. So I say x equals 2 pi over 3, and x is equal to 4 pi over 3. All right, now, what if the argument, the thing inside of sine or cosine or tangent or some other trig function, isn't just x or theta or the variable we're trying to solve at? If we've got something else going on here, well, then that would require more solving after we take inverse sine. So I've got it down to sine of a thing equals a number, so I'm going to go to the unit circle. And sine is 1. That happens at the top. So I'll color that in. And that's at pi over 2. So that means that whatever I'm putting into sine has got to be pi over 2 if sine is going to come back 1. So that means that this thing that I'm highlighting, this thing that I've put into sine, needs to equal pi over 2. So theta divided by 2 equals pi divided by 2. So to solve for theta, I'm going to need to multiply both sides by 2, and I'll get that theta is equal to pi. And that makes sense. You take theta, or you take pi, and you divide it by 2, and then you take the sine of it, and that is 1. Okay? But all of a sudden, you know, what if we'd had, you know, sine of theta divided by 2 equals negative 1? Okay, that's something I might do. Okay, well, that happens down here at the bottom. Okay, so that would be where theta divided by 2 was 3 pi over 2. Right? And if we doubled both sides, then all of a sudden theta would become 3 pi, which is no longer in our interval 0 to 2 pi. So that's some weird stuff will happen when you start messing with the argument of the trig functions. Okay, so it might basically kind of, I don't know how to describe it. It's kind of spirals out more solutions if you're dividing, and they can like shrink up if you've got something like sine of 3 theta. So let's look at one of those also. Okay. How about something like cosine of 2 theta equals negative 1/2? Now we already did cosine is negative half. About cosine of 3 theta equals negative 1. How about that? Yeah. And this will probably be the last example I've got for you on this video. Okay, so we've got it down to cosine thing equals number, so we're ready to go to the unit circle. Okay, I know where cosine is negative 1. That happens to be over here, far left. This is pi. Theta equals pi. So the thing that we're taking the cosine of has to be pi. Okay, so that means that 3 theta is equal to pi. And that's theta equals pi over 3. But if we were to add 2 pi and just go around from pi again, we'd have pi plus 2 pi is 3 pi. So what would happen if I said 3 theta equals 3 pi and then divided by 3? I get theta was pi. Okay, so this is another solution. And then what if I added another 2 pi to that? Plus 4 pi. Well, then I'd have 5 pi. So 3 theta is 5 pi. Okay, then you go to divide by 3, and you get theta is 5 pi divided by 3. So that's another solution. And all 3 of these solutions that I'm highlighting in green are in the interval 0 to 2 pi. Meaning that when you, if you multiply theta by, 2 or 3 or 4 or something, you could potentially need to look for more solutions outside of 0 to 2 pi before dividing away. Now that is in and of itself a little beyond the scope of the course, but again, if you were going to find yourself in a calculus course next year, I would feel real bad sending you to that calculus course without this type of knowledge. And that's all I got for you for this video.